Absolute value equations. At the end of this lesson, you should be able to answer, how do I find the different solutions to an absolute value equation? So let's define absolute value. It is the distance between a number and zero. And the absolute value of a number is always positive or zero. If you consider a number line, well, first of all, absolute value is written like this. This is the absolute value of 4. And if you consider how far is 4 from 0, well, it is exactly 4 units away. So the absolute value of 4 is 4. Whereas the absolute value of -3, it's written like, let me erase that. The absolute value of -3 is written like this. And -3 is 1, 2, 3 units away from 0. So the absolute value of -3 is 3. Let's consider these three equations. The absolute value of x is equal to 7. Well, what numbers are 7 units away from 0? Well, the first value would be 7. But consider to the left. What value is 7 units to the left of 0? That would be -7. So this equation has two solutions that satisfy it, both -7 or +7. If you consider the absolute value of x is equal to 0, well, what value satisfies this? There's only one number that is exactly 0 units from 0, and that is 0. And the final one, what value satisfies this? Well, what value is -6 units from 0? Well, when we consider distance, distance must always be positive or 0, so there's no value that is this. This has no solution. There's nothing I can plug in for x that would satisfy it. Consider this equation. The absolute value of x minus 3 is equal to 9. Let's just consider this logically. This is saying that some number is 9 units from 3. Well, if you think about what value is 9 units to the right of 3, that would be +12. What value is 9 units to the left of 3? That would be -6. So this is going to have two solutions as well. It's going to be -6 or +12. Now let me show you how to algebraically solve an equation like this. The absolute value of 3x plus 5 minus 6 is equal to -2. What you want to do is begin by isolating your absolute value expression. So I'm going to add 6 to both sides because my goal is to get this portion of the equation all by itself. Now that I've done that, that results in the absolute value of 3x plus 5 is equal to 4. The moment the absolute value is isolated, you're going to separate this into two separate equations joined by the word or, because we're going to have two values that are 4 units away from the expression in the inside. So one of the expressions is exactly as you see it, but the other expression, which I always write on the left, is equal to the opposite of 4, or -4. Now I have two simple equations that I'm going to solve. So I subtract 5 from each side, which gives me 3x is equal to -9. I then divide by 3, and I get x equals -3. And the one on the right, I subtract 5 and I get 3x is equal to -1. Divide by 3 and I get x equals -1/3. So again, there are two solutions that would satisfy this equation. Let's graph these two solutions on a number line. So I'm going to put 0. Here's -1, -2, and -3. Now when you're graphing -1/3, probably the easiest thing to do is put smaller little marks where 1/3 and 2/3 would be. So when I graph this, -1/3 is right here. It's just a closed circle, and -3 is right here. So there are two solutions. Now one of the things you might want to do to verify that each solution is correct is check them by plugging them back into the original. So if you do 3 times -3 plus 5, inside the absolute value symbols, -6 equals -2. So 3 times -3 is -9, plus 5 would be -4. So the absolute value of -4 is 4, and 4 minus 6 does equal negative 2. So the first one works. Now if I'm going to erase the values inside here and check my other solution. My other solution is negative 1/3. If I plug in negative 1/3, that would be negative 1 plus 5 would be positive 4. The absolute value of 4 is 4, and 4 minus 6 equals negative 2. So both solutions check. Let's check out example 3, which we're told to solve. So again, I need to isolate my absolute value expression. So I'm going to add 5 to both sides. So 3 times the absolute value of 2x minus 7 equals 9. Now I get rid of the coefficient of 3 by dividing each side by 3 because it's held by multiplication. So the absolute value of 2x minus 7 is equal to 3. Now that the expression is isolated, I'm going to separate this into two separate equations using the word or, which gives me 2x minus 7 equals negative 3, or 2x minus 7 equals positive 3. I'm going to solve each of these, add 7 to both sides. I get 2x equals 10, divide by 2, and my one solution is x equals 5. Add 7 to both sides on this one. I get 2x equals positive 4, divide by 2, and I get x equals 2. So my two solutions are x equals 2 or x equals 5. In example 3, let's look at what happens here. So I need to isolate my absolute value expression, so I divide each side by negative 2. And I get the absolute value of x minus 2 equals negative 8. Now hopefully at this point right here you recognize something funny is happening. Remember the definition of absolute value. We said that it must be positive or 0. Absolute value can never be negative. Therefore, there will never be anything that satisfies this equation. It's an impossibility. There is no solution. But let's just say that you didn't recognize it and you continued. This is not correct, but if you did continue and you left one of them exactly as you saw it, x minus 2 equals negative 8, and you made the other one x minus 2 equals positive 8. If you add 2 to both sides, you get x equals 10, and over here you get x equals negative 6. If you stop there and say that that's your answer, you're going to see that you would get it incorrect. But if you go on and you check these two answers, negative 2, and you plug in your first value of 10. 10 minus 2 is 8, and the absolute value of 8 is 8. So I have negative 2 times 8. That does not equal 16, so this one does not work. If I then plug in positive 6, I get negative 12 equals 16, and that is incorrect as well. So if you don't check your solution, you won't see that there's no solution if you miss it at this step. But just remember, the absolute value of an equation can never be negative. Okay, you should now know that most absolute value equations will have two solutions. Occasionally there'll be one, or it could be a special scenario where there's no solution at all.